All right, section 2.4, using postulates and diagrams. First, we need to do a little quick review. We need to define collinear and coplanar. So just a quick reminder of what these are. Collinear is points on the same line. Any points that are on the same line. Any points on the same line are collinear. And coplanar is any points on the same plane. So collinear, coplanar, we just need a quick review of what those are. All right, this vocabulary thing at the top is not on your notes, but it might be good to make a little note of this, or just remember what it says. A line is a line perpendicular to a plane. So a line being perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So if I have a plane and a line that is intersecting that plane, can intersect at this point and continue on. So it's saying it is only perpendicular to that plane. That line is only perpendicular to the plane if and only if all lines on that plane that intersect at that point also are perpendicular to that line. So back on, these red lines are on the plane. And we can have an infinite number of lines on that plane. But if that green line, if it's known that it's perpendicular to each one of those lines, then we know it's perpendicular to the plane. Okay, so postulate number 5, and you're going to have to learn these postulates. So postulate number 5, through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. So if we have any 2 points, we know there exists a line. And only one line. Only one line can pass through those 2 points. Postulate number 6. A line contains at least 2 points. So if we have a line, we know there must be at least 2 points. You need 2 points to make a line. If you just have one, all that is a point. We need 2 points to make a line. Postulate number 7. If 2 lines intersect, then their intersection is exactly 1 point. We talked about this in Unit 1. We have 2 lines that intersect. They're going to intersect in exactly 1 point. Postulate number 8. Through any 3 non-collinear points, there exists exactly 1 plane. So through any three non-collinear points, so points not on a line, there exists exactly one plane. And then similar to that, but just coming at it from the other side, a plane contains exactly, or a plane contains at least three non-collinear points. So a plane will always contain at least three non-collinear points. Postulate number 10. If 2 points lie in a plane, then the line containing them also lies in the plane. So if we have a plane, and we have 2 points on that plane, the line, remember, any 2 points, there exists exactly one line. So there is going to be a line here. That line is also on the plane. Postulate 11, if 2 planes intersect, then their intersection is a line. And this was also in Unit 1. We have 2 planes that intersect one another. They will intersect at a line. And that's, remember the floor in your room is a plane, the wall in your room is a plane, and where the floor and wall meet is a line. You can draw a line across the floor where it meets the wall. So where 2 planes intersect is a line. All right, so let's look at some examples and determine which postulate fits the example. So we have if we have these 3 points, and notice these points are not collinear, they're not in a line. So if we have these 3 non-collinear points, then they lie on the same plane. So what postulate would that be? Pause if you need to think about it. It would be postulate 8. Postulate 8 says through any non-collinear points, there exists exactly one plane. Okay, so letter B. If 2 points, then we have a line. So pause and think about that one. Which postulate is it? If 2 points, then a line. It is postulate 5. Postulate 5, which says through any 2 points, there exists exactly one line. For the letter C, if we have a plane, then we have 3 points on that plane. So what postulate is that? Pause if you need to look it up. Postulate number 9. Postulate 9, which says a plane contains at least 3 non-collinear points. So we started with a plane. We know that it consists of 3 non-collinear points. All right, these are 2 questions we need to be able to ask ourselves. What can you assume from the picture, and what can you not assume from a picture? So I'm going to give just a couple examples here. These are by no means the only examples of things you can assume and not assume. If I have a triangle, what can I assume from this picture? I can assume that all of the angles are going to add up to 180 degrees. That's about all I can assume. Well, I see that there are three sides, but I could assume that those three angles add up to 180 degrees. I have no markings. I have nothing else to help me out. Now, if my triangle was like this, and I see that all those angles are the same, then I could figure out that how much each angle is, what its measure is. If I have a triangle that looks a whole lot like a right triangle, but I don't have the little square in the corner, I cannot assume that it's a right triangle. But if it's got that square, I can assume it is a right triangle. So I need to look at the information that's given to be able to answer, can I assume this? Can I not assume this? So regardless of how close an image really looks to being a right angle, and remember, a right angle has perpendicular lines. These are perpendicular if that's a right angle. That's kind of what we're going to have a lot of situations like that in homework and in your work where something looks like they should be perpendicular, but you don't know if you don't know that there's a right angle. So you need to be able to ask those questions. Can I assume this based on the image? Can I not assume this based on the image? So let's look at these pictures, these diagrams. So which of the following statements cannot be assumed from the diagram? So any statements that cannot be assumed from this diagram. So our first statement is all points shown are coplanar. So let's look at the points. We've got point A, point C, point F, point E, point D, point G, point B. Are they all inside the plane? Yes. So they are all coplanar. So we're looking for cannot be assumed. So this one checks off. That's not one of our answers. But let's look at this next one. Line FG. Let's find line FG right here. Is perpendicular to line CD. Perpendicular to line CD. Or measure of angle CEF equals 90 degrees, which is that same thing. CEF being 90 degrees. Can we assume that those are perpendicular? No, we cannot. We do not have any indication that it's 90 degrees. We do not have any indication that it's a right angle or that they're perpendicular. We don't have enough information here. So this would be an answer. That is something we cannot assume. Let's look at the last one. Point C, E, and D are collinear. Point C, E, and D. Right. Yes, we can assume this one. They all lie on that same line. All right, then letter B. Look at that image. So which of the following statements, again, cannot be assumed from the diagram? Points E, D, and C are collinear. So we have points E, D, and C. Are they collinear? Yes. So that can be assumed. We see that line drawn through them, so we're able to assume that they are collinear without being told that they're collinear. All right, the intersection of line BD and EC is point D. So let's look at where line BD and line EC. And do they intersect at point D? Yes, they do. So that can be assumed as well. All right, how about line BD being perpendicular to EC? Line BD perpendicular to EC. Can that be assumed? No. We cannot assume BD is perpendicular to EC because we have no indication of if that forms a right angle or if it forms a 90-degree angle. We don't know. It looks like it'd be perpendicular, but we cannot assume that based on the information given. And then the last one is line, can we assume line EC is perpendicular to plane G? Now remember that one postulate or that rule that we talked about at the beginning, that for a line to be perpendicular to a plane, it must also be perpendicular to all lines on that plane that cross through that point. So line BD would also have to be perpendicular with EC for EC to be perpendicular with G. But since we could not prove, or we cannot assume that line BD is perpendicular, we cannot assume plane G is perpendicular. So this is also something we cannot assume. All right, example number 3, based on the picture, are the following statements true or false? I'm looking for true or false answers here. Angle CEF and FED are a linear pair. Can we assume that those are a linear pair? Or are they a linear pair, true or false? Based on the picture. Hopefully you said true. You can see that we have a line. CD is a line. And CEF and FED make up that line. Then we have angle CEF congruent to angle FED. Can we say that those two are congruent based on the picture? No, we cannot. We know that they're a linear pair, and a linear pair means that they're supplementary. Supplementary means they add up to 180 degrees. So we know that they have to add up to 180, but we do not know that they are the same. The only way that they could be congruent is if they're both 90 degrees. We don't know that. That EF, that ray EF, could be slanted one way or the other, making one angle larger and one angle smaller than 180. So this is false. Then we have CD equal to BD. Is CD equal to BD? And that would be false. We have nothing telling us how long any of these line segments are, so we just don't know, based on this picture, if they are equal or not. Line FG and line CD intersect at E. We have line FG and line CD intersecting at E. So that is true. Angle CEF and angle GED are vertical angles. We have angle CEF an angle GED. Are those vertical angles? Yes, they are, so it is true. And then the last one, line FG and line BD do not intersect. So line FG and line BD do not intersect. Can we conclude that they do not intersect? This is actually false. Even though in this image they do not intersect, we cannot conclude that, remember, lines are infinite and planes extend out infinitely. They might be slanting toward each other ever so slightly that eventually they could intersect. So this has to be false. We cannot assume that those are parallel and don't intersect. If we were told those two lines are parallel, then we know that they won't intersect. But if we're not told that, we do not know for sure. So that one is false. All right, make sure you do your 2.4 assignment and have a great day.